We've learned operators in our math class. I mean plus, minus, division, etc., which are arithmetic operators. But Java has many more types of operators, like unary operators, relational operators, logical and bitwise operators, etc. If you don't know about operators already, this chapter is for you. Keep watching.
In this chapter, we'll talk about operators. An operator is a special character that does some operation on operands. For example, if we have a plus b, then plus is an operator that does some operation on operands. In Java, we have different types of operators. Let's take a look at them. In this lesson, we'll talk about arithmetic operators, modulus operator, and assignment operator. But before that, we need to import the project. I have already bundled the project files as part of this chapter. You can just download it and import the project. And this is how you need to do so. Go to File, go to Import Project, click on From Zip. Click on Browse and select the zip file that I have bundled named Operators. Click on Open. Click on Import. Alright, now the project got imported. Let's expand the project. No need to worry about these packages and all. We'll definitely be exploring all these concepts in our future videos. So expand the source packages. This will contain the Java source files. Expand it. Expand operators, and then double click on arithmetic operators. This will open up the file. Now to talk about all these buttons and all these panels, we need to wait for our code to grow a little bit. So again, I'm saying it too often, but believe me, we're going to cover each and every topic in detail. Just trust me and follow me. Double click the tab to expand it. Arithmetic operators are operators that does some arithmetic operations. Take a look at this. We have additive operator that will find the sum of two operands. We have I equals 20 and D equals 10.1. This statement will find the sum of it and it would print the output. And we have subtraction operator. This will find the difference between the two operands. And we have multiplication operator. And the symbol that you need to use to multiply two operands is this, something that looks like a star. And we use / to perform the division operation. These are all arithmetic operators. Now we also have assignment operator. We use this operator to assign a value to a variable. And we have already seen this used in our previous examples. It's simple equal sign that we use to assign a value to a variable. And this is how exactly we did in our math classes as well. And then we have modulus operator. We use percentile symbol for this, and what this does is it will find the remainder of two operands or two variables. Let's run this program. Let's double click the tab to shrink it, and then you should not run the program using the run project, because doing so will run the entire project. And in entire project, it is expected that will have only one void main method. By the way, we'll talk about methods and all, but just remember that for every project we should have only one main method. But since in all these files, for example, let's open bitwise operators. we have main method here too. So we need to run each of these files individually. So to do so, we need to right click on the file and then click on Run File. Or we can also use a shortcut, which is Shift key plus F6. Let's click it to run the program. Alright, we got the output. Ignore all the junk here and let's just focus on the result. So I plus D is 30.1, I minus D is 9.9, etc. Great. Now you try to modify the code, give a different value, and try to play with the program. In this lesson, we will talk about unary operators. Let's double-click the file. Let's double-click the tab to expand it. We have unary plus operator, which tells Java that the integer is a positive integer. And we have unary minus operator, which tells Java that this number is a negative integer. If you don't give any operator here, by default, Java will assume this to be a positive integer. We have unary increment operator, and the operator looks something like this, two consecutive plus signs. And when we say a++, what this does is it will increment the value by 1. So it essentially does a equals a plus 1. Within increment operator, we have post increment and pre-increment. So in this instruction, we're doing post increment, which means we're printing the current value of a and then we're incrementing the variable a. So if you execute this statement, we would get 20. But the next time you use the value a, we get the increment value. For example, this instruction prints the incremented value. But when it comes to pre-increment, we're incrementing the value of a by 1 before we print it. So this statement will actually print the incremented value. And we have decrement operator. It has two consecutive minus signs. And what this essentially does is this. It does a equals a minus 1. It will decrement the value of a variable by 1. Even in here, we have post decrement and pre-decrement. In post decrement, we'll print the value of a and then we'll increment. So in this instruction, the value of a is currently 20. So in this instruction, it would just straight away print the value 20. But after it prints, it will decrement the value of a by 1. And the next time we use the variable a, we get the decremented value, which is 19. When it comes to pre-decrement, we are decrementing the value of a and then printing it. Finally, we have logical complement operator. This would just reverse the result of a Boolean value. For example, is a greater than b? We have a and b, and a is indeed greater than b. The result of this statement would be true, and the result of this statement would be false, because we're essentially having the same equation here, but we're kind of negating it. So the value of this instruction would be false. Let's try to run the program. Alright, here is the output. The initial value of a is 20. When we are showing the result of this instruction, a++, the value of a is printed first, which is 20. And then the value of a post increment is 21. In here, we're doing pre-increment. So the value of a is incremented and is printed at the same time. Because it's after the increment operator, we have the value a. So the current value of a is 21. It's now incremented to 22. In here, we're just resetting the value of a back to 20. Now we did post decrement, the value of a is printed, and then in the next instruction we have the decremented value, and hence the result is 19. In here we're doing pre-decrement. The value of a is decremented and printed at the same time. And we have logical complement operator. Is a greater than b? True. And the logical complement of a greater than b is false. We'll understand and we'll definitely be using all these operators in our future programs. In this chapter we will talk about relational operators and equality operator. A relational operator compares two operands and would give a Boolean result. We have greater than operator that will check if operand on the left is greater than the operand on the right. Similarly, we have greater than or equals to operator. It will check if a variable or an operand on the left is greater than or equal to an operand on the right. Similarly, we have less than operator and less than or equals to operator. And finally, in relational operators, we have not equals to operator to check to see if operand on the left is not equal to operand on the right. And we have equality operator that will check if operand on the left is equals to operand on the right. Note that this operator has two consecutive equal sign, because if we just give single equal sign like this, then according to Java this is a signing operator, just as we did here. If you want to compare two operands and check the equality, then you have to give two consecutive equal sign. And one thing to note here is all the relational operators will consider only numerical data types like integer, float, character. Let's run the program. Alright, is a greater than b? False. A is greater than or equals to b? False. A less than b? True. A less than or equals to b? True. A not equals to b? True. Is a equals b? False. Alright, now you can go and experiment with this program by yourself. In this lesson, we will talk about conditional operators. We have conditional and conditional or operators. Conditional operator defines under what conditions should an equation result in a Boolean value true. Let me explain you what I mean. Unlike other operators, conditional operators will take Boolean expressions on both the sides. For example, this expression would result in a Boolean value. It could either be true or false. Same is the case with this equation. Now for conditional AND, the only case where the result of this entire equation would be true is when these two equations result in Boolean value true. Otherwise, this equation would result in false. So in this case, a equals 20, it's true. Is b greater than a? It's true. So it's true and true, which would result in value true. In this case, we have true and false, and ultimately we'll get false as the result of this entire equation. And false true is also false. False false is also false. So only under one condition this equation will be true in case of conditional AND. That is when both the equations result in Boolean value true. When it comes to conditional OR operator, if either of these two Boolean equations result in value true, then the entire equation would be true. So true, true would be true, true, false would be true, false, true would be true, false, false will be false. We'll see the output in a moment. And then we have ternary operator. Unlike any other operator, ternary operator takes in 3 operands. For example, this is actually a shorthand of using if-else clause. We'll talk about if-else statement when we talk about control flow. Okay, basically what this equation is doing is we have an equation which would result in either true or false. If it is true, then this statement would be executed. In this case, we're just simply assigning a value a. Or if it is false, then this would not enter this section of this statement. Instead, it would print this, the value b. So essentially what we're doing here is we're trying to find the minimum value between these two operands or these two variables. If a is less than b, we would say a is smaller, and we're going to print the value a, because that's what we're assigning here. If a is less than b, then we're going to assign the value of a to this variable, min-val. If a is not less than b, then obviously b would be the minimum value, and we're assigning the value b to min value. That's what we're printing here. Let's run the program and see the output. Alright, what do we have here? Conditional AND, true, 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 and in any other case it would be false. And for conditional OR, the only time we would see false is when both the conditions or both the Boolean expressions result in false. And ternary value, so the minimum value between a and b using the ternary operator is 20, which is the value of a. Alright.
In this video, we're going to talk about bitwise operators. Personally, throughout my career, I have never used bitwise operators. And I would also recommend you not to give full focus on this topic, as it's not worth it. But if you're a student, maybe this will be helpful for your academics or for cracking interviews. So basically, all the other operators we have seen so far deal with variable, but in here we deal with the binary representation of numerical. For example, bitwise operators does not perform operation on 65, but rather it performs operations on its binary representation. The binary representation of value 65 in 32-bit format is this, and for -30 it's this. To better explain each and every bitwise operator, I might need to use annotations. Let's go there. Alright. We have unary bitwise complement, and the operator looks something like this. All this does is it will invert the bits. For example, 0 will become 1 and 1 will become 0. When we're trying to find unary bitwise complement of a, this is what the result would be. And when we convert this to a decimal value, we would get -66. Zeros have become 1 and 1s have become zeros. That's it, as simple as that. We have bitwise AND operator. For this, we need to follow a table. Here it is. We have only 4 possible combinations of 0 and 1. When it comes to bitwise AND, 0, 0 will become 0, 0, 1 will become 0, 1, 0 will become 0, and 1, 1 will become 1. So the only case we would see the result as 1 is when both are 1. So what we're trying to do here is we're trying to find bitwise AND of A and B.
So 1 0 will become 0, 0 1 will become 0, 0 0 will become 0, again 0, it's 0, 0, and we have 1 and 1 here, and that will make 1. Similarly, if you fill out all the bits in here, this is the output that we get, and when we convert that to a decimal value, would get 64. We have bitwise OR operator, and the operator looks something like this. We're trying to find the bitwise OR of A and B. When it comes to bitwise OR, there are 3 cases where we would get the value 1. If at least one of these 2 is 1, then the result will be 1. So 0 0 will become 0, 0 1 1, 1 0 would become 1, 1 1 will become 1. And if you calculate the bitwise OR of these 2 binary representations, this is what we get. And when we convert that to a decimal value, we would get -29. Cool. And then we have bitwise exclusive OR. In here, there are only 2 cases where we would get the value 1. 0 0 will become 0, 0 1 will become 1, 1 0 will become 1, and 1 1 will become 0. And if you perform exclusive OR on these 2, you would get this result, and that when converted to decimal would get -93. And we have sign to left shift operator. So what this essentially does is it's going to push, since we're doing a left shift by 4, it's going to push these digits towards left side 4 times. So what that would result in is all these 4 bits will fall, and we get 4 empty places here, and those will be filled with zeros. That's exactly what we have here. And when you convert that to decimal, we would get -480. We have signed right shift operator. This is similar to signed left shift operator, except it's going to push the digits towards right. In here, we're trying to push 2 places on the variable b. So what this is doing is it's going to push these bits towards right a couple of times. So these 2 would spill over and will disappear, and we get 2 empty locations here. And those empty locations will be filled with whatever is there in the most significant bit. So in this case it's 1. And that's exactly what we have here. And we have unsigned right shift. This will do exactly what signed right shift would do, except instead of filling the empty bits with the most significant bit, it will simply fill with zeros. So that would result in this value. If you run this program, these are the outputs that you're going to see. Go ahead and run it. In this video, we're going to talk about operator precedence. This can be better explained with annotations. So let's go there. Alright, let's say in our Java program, we have the following equation. 10 multiplied by 6 minus 3. Now, if we run the program, would the output be 10 multiplied by 6, 60, and minus 3 would be 57? Or would it be 10 multiplied by 6 minus 3, which would be 3, which gives us the result of 30? Which one is correct? This is ambiguous. We don't know how to evaluate this. So to solve this problem, Java developers introduced this precedence table. The precedence table tells which operator will have the higher precedence and which operator will have the least precedence. the operator that is listed on top will have the highest precedence, and the operator that is listed at the bottom of the table will have the least precedence. So the precedence increases as we go up and vice versa. So now coming back to this equation, let's see how we can solve this ambiguity. If you take a look at this table, the multiplication operator has the higher precedence compared to subtraction operator. So this part of equation will be evaluated first and the result will be computed with this. So the result would be 57. However, if you want this piece of equation to be calculated first, then you need to enclose it within a parenthesis. Now the result would be 30. Let's take a look at another example. 6 divided by 2 minus 1. So what is the result of this equation? Pause the video and find out. Okay, now let's solve the ambiguity. We have division operator and subtraction. Division has the higher precedence compared to subtraction operator. So this part of equation will be evaluated first and then the result will be computed with this. So the result would be 2. Sometimes in an equation we may have operators with equal precedence. Let's take a look at this equation. Now both plus and minus operators here have equal precedence. That's where this rule of associativity come into picture. Plus and minus, the rule of associativity says we need to go from left to right. So we'll first solve the left hand side equation and then the result will be computed with this. 7 plus 5 would be 12. Now let's take a look at another equation. So we need to go from left to right. So this will be evaluated first. Result will be evaluated with this, and the result of this entire equation will be evaluated with this. So we're going from left to right based on the rule of associativity. Similarly, we have associativity rules for other operators as well. Take a look at this equation. So the result of this would be minus 1. We're going from left to right. Both the operators are same, meaning that they both have the equal precedence, and as per the rule of associativity we need to go from left to right. Now let's try to put things together. Take a look at this equation. Find out the result of this equation where x equals 5. 10 minus 4 divided by predecrement of x minus 5. Pause the video and solve the equation. Okay, so in this equation we have 4 operators, of which the predecrement operator has the highest precedence. So this will be evaluated first. So 10 minus 4 divided by the predecrement of 5 would become 4 minus 5. And now out of these 3 operators which are left, the division operator has the highest precedence. So this piece of equation would be solved. 10 minus 1 minus 5. Now since both these operators has the equal precedence, we need to go with associativity rule, which says we need to go from left to right, and when we solve it the result would be 4. We solve this first and then computed the result with this. Now go back to our IDE and run the program. You would see the same results. In this video we are going to talk about statements and blocks. Let's first talk about statements in Java. The statements in Java is similar to statements in our English language. Let's take a look at the procedure to make tea. Go to kitchen, turn on the stove, put on the pan, pour some water, insert tea bag, serve hot, enjoy your tea. These are all the steps involved, Now if you see, each of this statement is ending with a period, and moreover, if I remove one of the word from here, this would result in not accomplishing our task of preparing tea, because I go to kitchen, turn on the what? I don't know what to do here. In Java programming, this would result in compilation error. Let's put it back. Now each of these statements collectively performing a certain task. Keeping this in mind, let's go to our Java program. So in the similar manner, we have statements in Java that ends with semicolon, whereas in English they end with period. That's it. Now we have multiple types of statements, which I feel is not worth knowing. We have already taken a look at some of those statements, like we have declaration and initialization statements, we have method invocation statements, we'll talk about methods later on, etc. Now let's talk about blocks. Each of the block would constitute n number of statements. It could be 0 or any number of statements. We can just have an empty block. A block will start with a curly brace and end with a curly brace. In this program itself, we have multiple blocks. This is one block, and within this block we have another block, which is this, and we have one more block. We have one more block as well. We're calling this block 1, block 2, and block 3. One important thing to note is the scope of variables. We have block 1 here, and it has a variable char a. Now inside this block we have sub-blocks, which is block 2 and block 3. The char a can be accessible from inside this block, and when I say inside this block, it also means inside the blocks inside this block. So the variable a is accessible within these blocks as well, block 2 and block 3, but not the other way. For example, in block 2 we have char b. If you try to access this variable outside this block, which is block 2, then we would get a compilation error, because the scope of a variable is restricted within the block where it was declared. In this simple example, we're just explaining a is accessible within block 1, block 2, and block 3. B is accessible within block 2, block 3, but not block 1. And C is accessible within only block 3, but not block 2 and block 1. Let's run the program. Alright, you see the output.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.